Hello everyone, my name is Sanjeev Kaushik Ramani and I'm here to present CertCoalesce, which is an efficient certificate pool for NDN-based systems. All of us know that NDN relies on public key signing to ensure integrity and authenticity for all data packets that are fetched in the network. One of the considerations for reliability of such signing is limiting the scope, that is, to ensure what piece of data can be signed by which key, and also the time for which each of these keys can be used to sign the data, which basically determines the requirements of least privilege principle. Traditionally, the PKI-based certificates are issued for relatively long periods of time, which runs into months or in some cases even years. Also, the traditional approaches requires an abundance processing and storage capabilities because the devices will or the requester will have to generate multiple public-private key pairs, save the private keys for deriving the certificates, and create multiple CSRs or requests and send them to the certificate issuer in order to receive the certificates. In our case, we were considering the use of IoT devices. Hence, this requirement becomes highly improbable. To eliminate the need for revocation and uphold the least privilege principle, we propose the CertCoalesce certification scheme. According to the scheme, we can potentially create a request for multiple simultaneously valid certificates with the use of a single master key, which is called the caterpillar key in our case. So the device will have to generate just one pair of public-private keys, convert them to something called the caterpillar key, and use that to request for multiple certificates. Uh, this scheme is built on the elliptic curve cryptography basis and also upholds forward secrecy. That is, of the certificate pool that we have requested, even the compromise of one of the certificates will not lead to the compromise of the other certificates in the pool. Let's have a look at the workflow or the design in more detail. So each of these devices will generate a public-private key pair and add on some attributes to make it a caterpillar key. So the master caterpillar key is required to be stored, which is the private key has to be stored so that it can derive the certificates that are received from the certificate issuer. So once the caterpillar keys are ready and the device can send this as the request for multiple certificates to the certificate issuing authority. So once the certificate issuing authority receives the caterpillar key, it uses an expansion function to generate something called the cocoon of keys or the cocoon keys. So the size of the cocoon set is based on the application, and the requester knows this as a pre-configured parameter. So the specialized naming convention for the cocoon keys is as shown in the slide. So you have the identity namespace, the key cocoon derived as in the derived values. Once the cocoon keys are generated, a randomly created secret is added to it in order to create the butterfly keys. The responses are then encrypted and aggregated and sent back to the device. The device, on receiving the certificates, will be able to decrypt the message and use the caterpillar private key that was stored in order to derive the butterfly private key and hence the butterfly certificate, and use these certificates to sign the data packets. So this is the overall design of CertCoalesce. Paper that submitted the abstract has more details on each of these operations, and you can reach out to us either through email to discuss more about this. Thank you.